In this video, we are going to do just a little bit more work in finding domain, and we're also going to look at some pre-rendered graphs and find their domain and range. So, the first thing we're going to do for this equation is notice that there is, in the denominator, there is a trinomial. And for trinomials to find, well, first of all, the denominator cannot be equal to 0. We have to now find the values that would make the equation 0. Now, guessing and checking would be pretty much a pretty laborious process, but what we can use is our knowledge of factoring from college algebra to figure out what values of x would make this denominator equal to 0. So, in this simple factoring problem, we are going to look at the two numbers to multiply to make 4 and add to make -5. Now, the multiples that multiply to make 4 are 1 and 4 and 2 and 2. Since 4 is positive, these could also be negative. -1, -4, and -2 and -2. But only one of these pairs adds to make a -5, and that would be this pair, the -1 and the -4. So we have x minus 1, x minus 4 cannot be equal to 0. This means if I FOIL the problem, the last number would be a 5, and the O and the I cables, or inside and outside multipliers, would make a -1x and a -4x to make a -5x. And of course, x times x is x squared. So this is the proper factorization of this trinomial. Therefore, x minus 1 cannot be equal to 0, and x minus 4 cannot be equal to 0. So if we add 1 to both sides, x cannot be equal to 1. So 1 would be one of the numbers that would make the denominator 0. And also if we add 4 to both sides, x cannot be equal to 4. So if we're finding the set notation of this, what we would easily do is easily make x define this set as the values of x where x cannot be 1 and 4. But the interval notation might be a little trickier. So we like to think of a number line. And we just need to basically say at 1 and at 4, x cannot be those values, but x can be every value above and below, above the 4 and below the 1 and between the 1 and 4. So the interval notation is going to go from -infinity to 1. And we're going to have parentheses around these because we're never going to get to -infinity, and we're not going to actually connect to the 1. Then we'll have a union of the group between 1 and 4. Parentheses on these because we're never going to connect to 1 and 4. And then another union going from 4 to infinity. And a parenthesis here because we're never going to get to infinity right there. So we use that. Don't use any brackets for this because the brackets would mean that we would have a filled in circle and then we wouldn't have the exclusion. So for our final three problems here, we're going to take a look at domain and range of each graph. Now, the domain is looking at the smallest x and the largest x value. In set notation, this would be x belonging to the group where x is between -4 and 4, inclusively. So we have -4, which is less than x, and less than or equal to x, which is less than or equal to 4. As an interval, that would go from hard bracket -4 to 4. In terms of its range, what is the lowest x or y value here? It looks like its lowest is 0 and its highest is 2. So y belongs to the group between 0 and 2 inclusively. And we would use the less than or equal to symbols to show that y is less than or equal to 2, and if we started here, y is greater than or equal to 0. In interval notation, this would be pretty simple to write, with hard brackets 0 to 2. So, in our second example, this open circle puts a little bit of a twist onto the domain. So if we have our x here, x is going to be between -5 and 3. So I like to put the -5 and the 3 there first. The x would be in the middle. Since this is a closed-in circle, we can actually get to -5, so this would be x is greater than or equal to -5, if we read it backwards. But this inequality does not have an equal to sign because we don't actually get to the 3. Then, what we need is, on this other side here for the interval notation, we're going to go from -5 to 3. The -5 would have a bracket, and the 3 would have a parenthesis. Okay, so now we're going to have our y knocking on the door here. For our y, we're going to go as low as 0, so that's going to be pretty straightforward, and high is 2. Now whether or not we fill in that circle is going to be the question. So x is greater than or equal to 0. We can see that because it does touch the 0 point right there. But we notice it doesn't touch here, but it does touch here. So, oh, I'm sorry, So what this means is that the y will go up to 2 and include the 2 because this is filled in. So yes, we want less than or equal to here. You might be confused thinking like, well, doesn't this open circle mean we can't get to it? But since we can get to it over here, we fill it in. So that's 0 to 2, hard bracket. So for our final problem, we have this somewhat of a stepladder that goes off and shoots off and goes well beyond. The arrowhead indicates that it keeps on going. So if we have x as part of the group, or x knocking on the door, we can see that it starts at -3 on the x. We can also see that it goes forever and ever and ever to positive infinity. So x is between these two values and can actually get to the -3. Now that's one way to put it. You could also write it this way. X is greater than or equal to -3. This is probably the way I would prefer it, because it leans right into your interval notation that starts with a hard bracket at -3 and then goes to infinity with a soft parenthesis. Now let's see if we can start with this kind of format for our range. Our range starts at 0 and goes to infinity, so y is going to be greater than or equal to 0, because it does start at the 0 and goes infinitely high. Therefore, this is going to be from 0 to infinity as well. And that ends just a little bit of extra work here that might give you the nudge that you need on your homework for this unit of finding restrictions in domain and finding domain and range.